Mathematics, Analysis and Approaches, Paper 1, Time Zone 1, HL, May 2025. This is question number 8 of 7 marks. There is Seema claiming that n is always greater than log of n to base 2. And we have to prove that 1 plus log n to base 2 is greater than log of n plus 1 to base 2. This is something that we have to prove. And in the B part, we have to prove Seema's claim using the result from A and use mathematical induction to prove that. So let's look at the A part first. 1 plus log n to base 2 is greater than or equal to log of n plus 1 to base 2. I need to prove this for all n belonging to z plus, which are positive integers. Now 1 can be written as log 2 to base 2, and therefore this would mean that log 2 to base 2 plus log n to base 2 is greater than or equal to log of n plus 1 to base 2. Now here again, I'm going to be applying the laws of logarithm. Basically, log of a plus log of b is equal to log of ab. That's what I'm going to use here. So I can quickly write this as log of 2n to base 2 is greater than or equal to log of n plus 1 to base 2. So again, I can remove log from both the sides because of the same base. So I can write this as 2n is greater than or equal to n plus 1. Now this is going to be true for all values of n. Okay, twice of any integer is going to be greater than the integer plus 1. All right, and because this is true, since this is true, the above will be true. If you want to, you can probably write a statement here saying that since. Now let's look at the B part, which talks about mathematical induction to prove Seema's claim. When we are doing mathematical induction, we will have 3 steps. Step 1, or the first step, is simply proving whatever statement we have for n is equal to 1. And then we have an assumption step where we are going to be assuming that it's true for n is equal to some value k, and then we are going to do the induction step where we're going to prove n is equal to k plus 1. And then we confirmed that because it's true for n is equal to k plus 1 with an assumption that n is equal to k is true, and given the fact that n is n is equal to 1 is true, we confirm that the statement given itself is true. So let's look at what is Seema's claim. N is greater than log of n to base 2. So this is Seema's claim. N is greater than log of n to base 2. So I'm going to go with the step 1. For n is equal to 1, I can see that 1 is greater than log 1 to base 2. Log 1 to any base is going to be a 0, and therefore 1 is greater than true, which is true. I'm going to call this statement as, let's say, P of n. Therefore, P of n is true for n is equal to 1. Now I go to the assumption step. So here I'm going to say, let P of n be true for n is equal to k. So P of k is k is greater than log k to base 2. This is going to be true. That's my assumption step. Then I go to the third step. Now, before I can go to the third step, I'm looking at, okay, what am I supposed to get at the end of it, right? I'm going to do the proof for n is equal to k plus 1. So ultimately, I'm supposed to get k plus 1 is greater than log of k plus 1 to base 2. Now, this is what I need to get, okay? So what I know from the assumption step is that k is greater than log of k to base 2. I'm going to add a 1 on both the sides. So 1 plus k is greater than 1 plus log of k to base 2. Now let's look at part A. What I had in part A is this. 1 plus log n to base 2 is greater than this, which is what we have here. Yeah. So instead of, I know that 1 plus log of k to base 2 is greater than or equal to log of n plus 1 to base 2. So that's log of n plus k plus 1 in this case to base 2. So combining these two statements, I can write 1 plus k is greater than log of k plus 1 to base 2. Log of k plus 1 to base 2, and that is the proof I have here, right? Hence, by induction, I can say 1 plus, hence by induction I can say that the Singh's claim is true, which is n is greater than log n to base. That is it for this video. Thank you.